Dr. Sara Gottfried, welcome to a whole new level.
Dr. Mean, so happy to be here with you.
I've been so excited about this conversation, and I know our listeners are going to learn a lot. I'm so excited that you're here. And I think we should just jump in with really the big picture. Why should the average person care about metabolic health? And why should someone who doesn't necessarily have prediabetes yet or have type 2 diabetes be concerned about their glucose tolerance and things like metabolic flexibility?
Love that question. I feel like metabolism is the foundation of your health today and tomorrow. And I think a lot of people misconceive the word metabolism. They think that it's related to their weight or maybe how much belly fat they have, how much fat mass they have. And the truth is, the concept of metabolism is so much deeper and broader than that. It's really the aggregate of all of the biochemical processes that are occurring in the body. That includes the metabolic hormones, things like insulin, cortisol, leptin, testosterone, growth hormone, the full list. And so these really drive so many factors when it comes to health, and it determines how you feel today, how you're going to age over the next few decades, and really it connects to purpose and meaning. So I think that's an essential thing to understand about metabolism.
Oh, that's so interesting. The last thing you just touched on about purpose and meaning. I would love for you to elaborate on that more, if you would.
Yeah, I remember the Dalai Lama said something like, the world is going to be changed by Western women. And I think we could argue that particular point. I don't know that it's going to be Western women, but I would say that the world is going to be changed by people who have good metabolism. It's going to be changed by people who really understand the drivers of metabolism. They're paying attention to them, and they're realizing that there are signs of dysfunction that begin way earlier than an abnormal fasting glucose. So that's what I mean when I say that I think this relates to the mission that you have in life, regardless of what that is.
I love that so much. And I think about it very similarly because, our metabolism is our engine and it allows us to do the things that we want to do and really embody whatever that vision or purpose we have for our lives are. Without a well-functioning way of processing and making energy in the body, it's going to be very difficult to, enact that vision and make it a reality. Not to mention how much metabolism has to do with our mental health and the way we think and feel and our energy and sort of our get up and go, all of which, of course, has to do with, how we can actually enact that vision for our lives in the world. So I love that. And I think it also relates so much to what's happening with COVID right now, because, we're seeing that a big determinant of outcomes in relation to this virus has to do with our underlying metabolic health. And, that it really is time for each person to kind of make that decision individually to take control of their metabolic health, because that is one of, in my personal opinion, one of the best ways that we can support our communities and our families and in, boosting our resilience in the face of this monumental threat that we're facing. So yeah.
Yeah. So you said a few things that I think are so pivotal, Casey. Hopefully I can call you Casey.
Of course.
So one thing you said is there's this epidemic within the pandemic, and that epidemic is metabolic dysfunction. I think that's such an important point to emphasize. It's not like this virus just happened upon us and we're just these innocent victims who fell prey to this virus. We've been meeting this virus in the middle for a long time in terms of what we've done with metabolic health. So I think that's a really important point to make. And there's even disinformation about what metabolic health is and how you create it. We can hopefully get into that a little bit today. But you also connected it to mental health. And I really appreciate that point, because we know that, looking at some of the citations over the past year and a half, we know that depression has tripled during the pandemic. And I think we're finally at a point now where we're realizing that metabolism is not something that we outsource to the internist or, just talk about with our family practice doctor. We need to really be democratizing this data so that people have access to it, and to connect these dots so that even psychiatrists, even people in the mental health profession realize that metabolic health is a tool in their toolbox. Like, this is something that we can be taking on, and it's so important in terms of anxiety, depression, suicide, some of these other factors that really have been unveiled, unmasked by the pandemic.
Absolutely. And I think this leads to really the kind of logical next question that people might be thinking, which is how do we improve our metabolic health? I think it's the first step is just helping increase the awareness about the fact that this pandemic is not just a viral pandemic, it's a metabolic health epidemic, like you said. And that comes down to every day our choices that we're making that either support our metabolic health or do not. And you just wrote an incredible book that gets into this in great detail and is really kind of the ultimate comprehensive guidebook for helping women especially achieve their metabolic health goals and their wellness goals by optimizing metabolism. And it's called Women, Food, and Hormones, and it's coming out right now. And it was really monumental to read because it is really a playbook with deep research-based, knowledge that tells people how to enact a low carbohydrate diet in a way that honors their hormones and that doesn't kick their hormones off in a bad direction, and focus really on nutrient density and a really holistic approach to food. And so you talk in the book about how to achieve metabolic health, and specifically looking at low carbohydrate diets, and talk about why a traditional ketogenic diet may not work as well for women as it does for men, and why certain adjustments to that traditional diet should be made for women who are doing a low carb diet. So I would love if you could talk to us a little bit about why the standard ketogenic diet can be counterproductive in some women when done sort of in the traditional lens, and how we might start thinking about frameworks for tailoring it for women to be more effective, specifically through your protocol that you elucidate in the book, the Gottfried protocol.
Yeah, great question. I feel like a lot of my books come from listening deeply in my medical practice. So I run precision medicine at the Marcus Institute of Integrative Health at Thomas Jefferson University. And, what I noticed about 7 or 8 years ago was that I was suddenly seeing these keto refugees. I was seeing these folks who were trying a ketogenic diet. I see both men and women, but I was especially seeing women who would go on a ketogenic diet or keto with their male partner or with a colleague from work. And the men would do very well, and the women would hardly notice a change. Maybe they even felt more inflamed or gained weight. They also had other downstream consequences that I think are important to list, which you often don't hear from some of the keto thought leaders. Things like 45% of women in some series have menstrual irregularity. Some of them have thyroid dysfunction. Some of them experience high cortisol levels, and cortisol is part of metabolic health. And so what I realized, a lot of them also had sleep issues, because for some women, the ketones that are produced by a ketogenic diet can be very activating. Now, that can be a good thing for your brain. A lot of people, when they're on a ketogenic diet, feel like they hear the angels singing, like they have this mental acuity that feels so good. And yet that can backfire and make it very hard to unwind at night. We know that women have about double the rate of insomnia compared to men. So these are some of the things that I was seeing in my practice. When I see that, I do two things. I go to the literature to see what the science tells us, and then I also try it myself. So when I went to the literature, maybe you could say I wasn't so surprised to find this, I found that most of the data was on men. So something like 80% of the series were in men only, because, this is one of the biases we have across the board in scientific evidence, that Women are considered too complicated, especially women who are menstruating and that hormonal variable. They just want to bypass it by looking at men. But women are not just small versions of men. They're not men with breasts. We are quite complex and quite different, both sex differences and also gender differences, which we can get into. And so what works for men doesn't necessarily work for women. So when I saw this bias that exists in the literature, I then tried it myself. So this was going back to 2015, 2016, and I failed. I failed the first few times that I went on a ketogenic diet. And I failed in a couple of ways. Didn't lose weight. In some measures, I would say my inflammation got worse. I didn't get the metabolic flexibility that I was hoping to get from a ketogenic diet. I found in retrospect that there's some genomic drivers involved with this, which hopefully we can get to. I wasn't dealing with the saturated fat, all the bacon and the fat bombs and the other things that I was eating just weren't getting processed by my body in a healthy way. So this got me to adjust the protocol to look at, okay, how do we tweak this? Because in precision medicine, we love to do these N of one experiments where each person serves as their own control. It's what I do with patients, is what I do with myself. I've got a constant N of one experiment going on. And I realized that if I had my detox pathways fully open, if I was methylating properly, if I was getting the whole foods that I needed, especially the allium vegetables that help me produce glutathione, that help me detoxify, especially estrogens, if I was getting the cruciferous vegetables, especially the broccoli sprouts that I love, that help me with, again, detoxification of estrogens. If that detox piece was in place before starting a ketogenic diet, it was much more effective for me. Now, this isn't about me, of course. What I want to do is to figure out, okay, what works more broadly across the board for both men and women. And then I started to experiment with my patients with their permission. And I included a lot of the cases in the book of people who were very successful with this, as well as people who, just lost a small amount of weight, but it was still a significant impact in terms of metabolic flexibility. So those are some of the differences that I saw in women compared to men. There's even in the literature this idea of the keto paradox, that it works so well for men, doesn't work as well for women. And we want to pay attention to those differences, not just gloss them over, but to understand what are some of those differences in metabolism? What are some of those differences in response to food and lifestyle that help us understand both men and women and kind of help us raise the boat, raise the bar. So I think understanding these sex and gender differences really helps all of us, not just women.
Absolutely. And, that part about the cruciferous vegetables and detoxification and thinking about these pathways, this is something about the ketogenic diet that has always sort of made me a little weary, because I am plant-based, and there's this idea that you can't be plant-based and also get into ketogenesis, which I actually think is not true. I woke up with ketones of 2.0 this morning, on a plant-based. I did just do a 36-hour fast, but it is very possible, to balance these worlds. And I think that, the one of the things that drives me in terms of being plant-based is exactly what you were talking about, the detoxification, the plant chemicals that I'm trying to get into my body to optimize, my liver pathways, my phase 1 and phase 2 detoxification, my glutathione production, and then of course my microbiome through the impact of fiber and other phytochemicals to improve my elimination, which of course it's talked about in many of your books, has a lot to do with our process of processing hormones, especially our sex hormones like estrogen, that these are processed in our liver and when we, poop essentially. And when if we're slowing those things down by eliminating a lot of these nutrient rich foods on what might be a more traditional ketogenic diet, there's going to be potentially downstream effects. So that's one of the things that I loved so much about your book, was really focusing on not just the macros, like exactly what macronutrient composition in the food, but what's the actual quality of the food that people are eating. And as we know, food is information. And there's a big focus in your book about really giving the body the right information to be able to produce hormones, eliminate hormones, keep the balance in check. So that, I think, is just a huge step forward in terms of what your book brings to the conversation about the ketogenic diet. That just moves beyond macros into really thinking of food as the information that it is. So I'd love to.
Can I say a quick thing about that?
Yeah.
Sorry to interrupt. You raised so many important points there, and I want to highlight a few of them. When I first was looking at, okay, what is the diet that provides the best metabolic function? What I found was that it's plant-based. It's whole foods, plant-based, 100% plant-based. There's a lot of evidence behind this. And when I followed that food plan, I didn't do that well. It didn't actually help me with metabolic flexibility. So even though there's this literature that in a population level, whole foods, plant-based is one of the most healing in terms of metabolism, it didn't work for me. And I think this is part of the personalization that we really need in medicine going forward. And what, some of the drivers in my case relate to a history of disordered eating. I have particular energy regulation, genomic pathways that are associated with high satiety, high appetite. So it takes a lot of food for me to feel sated. And so I eat too much when I am plant-based. Whereas one of the benefits of a ketogenic diet, and we're talking here about a clean, well-formulated ketogenic diet that does all the things that you listed, has the prebiotic fibers that helps you to make those benevolent microbes that are involved in glucose regulation, such as Akkermansia muciniphila. It also helps you with methylation from those dark green leafies. It helps you with other forms of detoxification. What I found was that the ketogenic diet, because the production of ketones helps me with satiety, that was the missing piece for me. So I wanted to dial that piece in, because it's not that I'm saying everyone should go on a ketogenic diet. I don't think that is the right approach at all. It's more that we have to personalize and figure out what's best for the individual.
That's exactly right. And that's why the message that you've been promoting of the N of one experimentation, fits so importantly in here, I think, because, someone might listen to this and say, oh, well, her ketones are up with a plant-based diet. So that means I can just eat a plant-based diet and my ketones will rise. That is not the case at all. It's been 2 years of dialing in with a continuous glucose monitor, exactly what plant-based foods work for my body, don't cause a glycemic excursion, how to pair foods to keep the glucose levels flat, how to incorporate intermittent fasting into that in order to see the numbers change. So, I don't want to say it's impossible to do it blindly, but having that data and that feedback to tailor your diet, can be so helpful. And essentially to get what I think is a great, point is that you can achieve ketogenesis or metabolic flexibility, I think, probably from almost any dietary philosophy. And those different dietary philosophies are going to work for different people's bodies based on many of the things you talked about, genetics, history, et cetera. And the beauty of sort of the N of one experimentation is that you can dial in whatever that philosophy is to achieve the outcomes you want. For me, the outcome I want is metabolic flexibility, and to know that my body's pathways to make ketones, i.e. burn fat and both fat and carbs, not just carbs, that they're active, that those pathways in my cells are working. And so that feedback loop of trying different things out, seeing how it affects, my glucose, seeing how it then results in the downstream production of ketones, can create essentially the personalization of this particular philosophy that seems to work well for my body. So
yeah, I love that. I would say part of what you and I are expressing here is that we're food agnostic.
Yeah.
So you have found what works for you. I found what works for me. They're not exactly the same because we've personalized. And I think that's a really important message, because often we can get into this state of tribalism around food. It's almost like talking about religion or politics. And it's not that you have to eat a particular way. I have a lot of patients who were cases for the book that I just wrote who were vegan. I had a lot of patients that were vegetarian. I had patients who were on the carnivore diet before they came to me and we started this protocol. So I just want to cast a wide net here that we are food agnostic. I think that's what I hear from you all the time. It's what I hear, what I hope comes across in the work that I put out into the world.
Absolutely. And I think that data can also help move us past diet tribalism by letting us understand what actually works for our body, which could look like many different, permutations, which has a common underlying theme, I think, of food quality and nutrient density. And something that in your book that I loved was, I think it was in chapter 4, which is a chapter called The Keto Paradox. And it talks about how to incorporate intermittent fasting into this regimen and how it can be really helpful to allow people to stay in mild ketosis while having a slightly higher carbohydrate intake than maybe what would be allowed on a standard ketogenic diet. So I'd love to hear a little bit more about how you incorporate intermittent fasting into your protocol. And if that can serve as a bit of a buffer to allow women who may need to eat slightly more carbohydrates for optimal functioning to still be able to achieve ketogenesis, and how you work that into the protocol.
What's lovely about intermittent fasting is that it's programmed into our DNA. Our DNA is designed to have these periods of metabolic rest. It's the way that our ancestors evolved, depending on the seasons, depending on food scarcity and what was available. So we're already programmed to do this. In many ways, I think of intermittent fasting as a backdoor to ketosis, as you described with the fasting that you did, how it raised your ketones to 2.0. What we know is that intermittent fasting is a way to tolerate more carbohydrates. So with classic keto, what typically happens is that people go on a 70-20-10 macronutrient ratio, where 70% of the calories are from fat, 20% from protein, a moderate protein diet, and then 10% from carbohydrates. And what I found was that for some women, that's just not enough carbs, especially women who are more stressed, who have high perceived stress. And I'm talking now to a lot of those women that are between the ages of like 30 and 50, 55. And I say that with so much love because I'm one of them. And based on the amount of exercise that you have, the amount of stress, as I just mentioned, the number of carbs that you need varies. So being able to personalize that, I think, is helpful. There's a particular sequence that I found to be most advantageous in these N of 1 experiments and the research that I did on a ketogenic diet adapted to women. The first is detoxification, really make sure that those pathways are open by the mechanisms that we just talked about. Then a ketogenic diet, but I like to use net carbs, not total carbs, because that again lets us pay attention to those prebiotic fibers that are so important for metabolic hormone balance. And then the third piece is to layer in fasting, to not do it in such an aggressive way that you're raising cortisol, because cortisol is one of those high priority hormones that can really kind of crash the party and cause issues with metabolism. And so right now, looking at the sum of data on fasting, you'll get thought leaders saying controversial things and conflicting things. But I would say my take on the scientific literature after looking at thousands of studies is that somewhere around a 14-hour overnight fast is probably the most healing in terms of downstream signaling, changes in hormones, changes in metabolomics, without triggering a cortisol spike. So other people like longer fasts. When I first started, I was doing a 16-8 protocol because that's what a lot of the science supported. Again, most of it in men. Some people like longer fasts, 24 hours, even longer. And we know that can be stressful for some people. So I would say, based on the literature, 14 hours is really the ideal overnight fast. And that's where I like to start with my patients. And for most people, depending on your metabolic flexibility, somewhere around a 14 to 18-hour overnight fast is where you start to produce ketones. There's some sex differences there. Men often produce ketones sooner. So we just want to be mindful of those.
Yeah, yeah. And I think the concept of fasting as a potential stressor is such an important point, and one that comes up a lot. I get asked by patients often, if if fasting is, too much for women at some points in their life, like if there's already a lot of stress going on, or if they are training, for a race or something like that, or if they're in a particular part of their menstrual cycle. Can fasting be something that sort of puts them over the edge, or should they dial it back during those periods? And like with everything, I imagine there's sort of an ebb and flow to these things of when to kind of go hard and when to pull back a little bit so as not to overload, the sort of allostatic load on the body. But what's your framework for thinking about when people should dial this up and when they should sort of dial it down, if at all?
Well, what I like to do is to test. So this gets us back to the N of one study. So I like to look at a number of different factors in terms of stress and cortisol. And there's many proxies for this, such as heart rate variability, or, looking at on my Garmin, you can look at your body battery. On my Aura Ring, you can look at readiness and also track HRV. So there's many ways that we can track this. My general advice is to really develop interoception. So interoception is that sense of what's going on in your body, being in tune with it. It's something that I think was stamped out of us when we went through our medical training, when we couldn't eat when we needed to eat, couldn't go to the bathroom when we needed to, couldn't sleep when we needed to. And so a lot of us have sort of a broken feedback system and can't really tell what's stressful. Our set point is so high with cortisol and stress that it's just hard to assess that. So sometimes having these other sensors can be very helpful. So I listed some of the ones that I find to be helpful. What I notice with the menstrual cycle, since you asked about that, is this is one of those infradian rhythms that I think women benefit from paying attention to. I take care of a lot of athletes. I've got an NBA team that I work with, and I've got some Olympic athletes that are part of my practice. What I find is that the ideal time to fast and also to go for gains is right around day 9 through 14 of the menstrual cycle. So that's the period of time where testosterone is at its peak for women who are still cycling. Estradiol tends to peak around day 12. This is based on a hypothetical 28-day cycle, which not everyone has. But that's really when you want to go for gains. That's where you want to go for speed. If you're a runner, that's where you want to go for muscle gains. If you're someone who likes strength training, I hope all of our listeners like strength training. It's so important for you as a driver of slowing down the aging process. And progesterone is relatively low. So that is really the ideal time. The worst time of the cycle is mid-luteal. So right around day 20 to 28, which is when progesterone peaks, you get another small peak of estradiol, but you've got that estrogen progesterone tango happening. That's where women tend to have much more in the way of carb cravings. So especially women who've got some metabolic dysfunction and they have maybe premenstrual syndrome, they've got more food cravings. They've actually studied this, kind of looking at women in the wild who eat about 260% more carbohydrates, refined carbohydrates, in the mid-luteal phase. So I would say that's a time where it can be harder to fast. So I like to set people up for success. You can do a very slow on-ramp in terms of fasting, but I would, for those who are still cycling, I would say focus on that period of time from day 9 until 14. Like that's where you'll find intermittent fasting is the easiest.
That is great insight, and something I didn't know too much about. And the statistic about the increased carb consumption in the mid luteal phase is unbelievable. It just really goes to show how much hormones are driving some of our behaviors, and how important these balances are. And this brings me to something else about your book that I'd love to hear your thoughts on, which is you talk about some hormones that I don't think we normally think about very often in the context of metabolic health. We think a lot about insulin, and sometimes people are clued into cortisol, but you talk a lot about testosterone and growth hormone, which just are not buzzwords in this field, especially when it comes to women. So I'd love to hear just sort of an overview about why these hormones are important for our overall metabolic health, and then how we can help keep them in balance through the choices that we're making.
Let's start first with testosterone. And testosterone is super interesting because it's thought of as the male hormone, but a lot of people don't realize that it is the most abundant hormone in the female body. So yes, men have 10 to 20 times more testosterone than women do, but it's our most abundant hormone. So it is the hormone that we are exquisitely sensitive to. Now, once again, a lot of the literature looking at metabolic health and testosterone is from men. And with men, what we typically find is that low testosterone, the low T syndrome that we see in men, is associated with metabolic dysfunction. So we see more diabetes, we see more, problems with dysglycemia, we see more insulin resistance in men with low T. Women are a little more dynamic. So with women, what we want is testosterone to be in that Goldilocks position where it's not too high, it's not heading in the direction of polycystic ovary syndrome, but it's also not too low. So when it comes to metabolic health in women, what we're mostly looking at is low testosterone. High testosterone is a little bit more complex. We could talk about that separately if you'd like. But testosterone is one of those hormones that tends to decline in both men and women starting in your 20s. So a lot of folks don't realize that your peak is typically around 20 to 25. There's about a 1% decrement in testosterone production as you get older than that. And the decrement can be accelerated by being a stress case, someone with high perceived stress and high cortisol. So that was my story because I'm always learning from my own experiments. And what's amazing to me with testosterone is that a lot of folks don't realize, women especially, that low T is part of the story for why they don't feel good. So it's involved, of course, in sex drive. That's probably what it's most famous for, but it's also involved in muscle mass. So if you're working out during the pandemic and you got your weights and you are so consistent about exercising and you're just not seeing a response to all of this strength training that you're doing, it could be related to low testosterone. It's also involved in a number of other factors, especially in women. It's involved in confidence, agency. There's even a study looking at women MBA students showing that women who have higher testosterone in that Goldilocks position are more likely to be comfortable with risk. So we want to be thinking about these broader contexts for these hormones. That's testosterone. So women are exquisitely sensitive. It's the most abundant if you look at your level of testosterone on a lab test compared to other hormones. And then growth hormone is one of those hormones that I didn't pay a lot of attention to going through my training. It does kind of what the name implies. It helps you with growth and repair. It's responsible for height when you're a child. So children who have short stature, who meet criteria for growth hormone deficiency, sometimes will get growth hormone injections to help them reach peak height. But as you get older, it's also involved in, I think of hormones in two different camps. I think of the catabolic hormones, the ones that break things down like cortisol. And then I think of the anabolic hormones, the things that are involved in growth and repair, such as testosterone and growth hormone. It also has a key role when it comes to insulin function and belly fat, visceral fat. So this is another one of those hormones that can decline. There's a significant sex difference here. So sex differences are biological, whereas gender differences are sociocultural constructions. And the sex difference is that women tend to make growth hormone more continuously, whereas men tend to be more pulsatile with longer periods between their pulses of growth hormone. Most of the pulses occur at night. The other factor is that women actually make more growth hormone than men until they go through menopause. And then after menopause, we make much less. And a lot of women notice that difference. They just have more fatigue. They have more belly fat. They notice this redistribution of their fat deposits. There's a lot of hormones involved in that. It's not just growth hormone, it's also insulin and estrogen and testosterone. But a lot of women notice that redistribution, like their clothes just don't fit quite the way that they used to, even if their weight is the same. So those are some of the metabolic hormones that I pay a lot of attention to. Frankly, there's dozens of them. And I think the key is to figure out, okay, what are the main drivers for you? And then how do we use diet and nutrition and lifestyle redesign to address these metabolic hormones and improve metabolic health?
That was such a helpful overview about those two hormones. And I can imagine people are thinking, oh gosh, like how do I know where I'm at with these? And is there anything, general things that are associated with keeping these in the right balance? And, specifically thinking about something like testosterone in women, are these tests that you recommend people asking their doctor for? I know you've tested them in yourself because you mentioned this in the book and in some personal case studies, but something that you would like to see sort of more on the standard metabolic panel.
Yeah, I think we all deserve a metabolic panel, but you also don't have to, assign the role of gatekeeper to your physician in order to improve these things. So I'm a big fan of making this accessible to everyone. It's why I use questionnaires in all of my books. And these questionnaires are a way of predicting your level of these hormones. So I've got a questionnaire for testosterone, another questionnaire for growth hormone. So that can be, I think, a great first step. I practice precision medicine, so I like to measure these things. I really agree with, I think it was Lord Kelvin who said, what you measure improves. And so I'm a big fan of measuring. I find that really helps me step into action and holds me accountable. So I like measuring these levels. But one of the things you may hear from your doctor is that, oh, we don't check those hormones. They fluctuate too much. And yet, if you're 32 and you're trying to get pregnant, they'll check all those hormones. If you're having trouble conceiving, they'll check your thyroid, they'll check your cortisol, testosterone, estradiol, progesterone, probably not growth hormone, but they will look at all of these hormones. And to me, that is a double standard. To be told on the one hand that it fluctuates too much and it's not meaningful when you're not trying to get pregnant, and yet it is meaningful if you are trying to get pregnant. So that's something that I think we have to undo. It brings up a larger point, Casey, that I think we're dancing around a little bit, which is this role of the gatekeeper with the physician, because I think that part of the problem and how we got into this big mess metabolically is that, how much time do you actually spend with your doctor? I spend less than 1% of my time. I mean, it's more like 0.001% of my time. The rest of the time, the 99.99% of my time is me doing these experiments and, kind of outside of the doctor's office. Why would I want to outsource my metabolic health to an annual measurement of my fasting glucose and my hemoglobin A1C? I think it's very important to democratize this data so that we have access and can do these types of experiments that allow us to improve metabolic health.
Amen. I mean, that is so beautifully said. And I think something for anyone who I hope every single person is going to pre-order this after listening to the podcast, but Women, Food, and Hormones, there is quite a lengthy section in the book helping people understand how to track their own metabolic health at home with things like the glucose ketone index, and other simple markers that you can check every day and understand where you're at, where you're heading, how things are improving. Really a very empowering way to approach these things, because it's something you can do at home and that's in your own hands.
Your CEO said something about this that I really loved. If I can like crush on Sam for a minute.
Yes.
So I was listening to an interview that he was doing where he was saying, with levels, what is the problem that you're trying to solve? And he was talking about how he used to have oatmeal and orange juice for breakfast. And turns out that was spiking his glucose quite severely, and it was causing problems with metabolic health. And he said, initially I thought the problem to solve was ignorance. I'm paraphrasing here. And he said, what I realized actually is that it's not ignorance, it is misinformation. And I think part of the misinformation is the way that we are, as consumers, kept at arm's length from this data. So the more that we have that data at our fingertips to empower us to make decisions, so that we're not just, following some diet that our doctor told us to follow, but instead we've got this immediate feedback, I think that changes everything. So, there's many different pieces to that misinformation, but I think part of it is this issue of being disempowered by turning over our data to physicians. And I say that with so much love and respect for my fellow physicians. It's what you and I were taught to do.
Yeah.
But now we're disrupting that system.
Absolutely. And I think this leads to the next thing I'm so excited to talk to you about, which is your research on understanding how prediabetes develops and how we can better diagnose this, because this is an area where, talk about disempowering information and lab tests. We have 90 million people in the United States with meeting criteria for prediabetes, and about 85% of them do not know that they have it, which is an atrocity. And looping back to COVID, very much related to the outcomes that we're seeing in this pandemic. But not just that, people are walking around living their lives not feeling great, maybe sort of dealing with FLC syndrome that Mark Hyman talks about, which is feel like crap syndrome, and have no idea, and yet feel a lot of trust in the system that says, oh, you came in last year and your glucose was 102 milligrams per deciliter, so you're just right on the cusp and nothing to worry about. It's fine, even though what we really know is that that's low pre-diabetic range, which means that metabolic dysfunction is in full force and has probably been going on for over a decade. But the tests and the way that we look at this do not capture that, and don't really give any power to the individual to really make changes. So I would love to dig into a bit of an overview about the work that you're doing on multi-omic phenotyping of prediabetes and how this could potentially open up a new understanding for the development of the disease, but also how we think about potentially diagnosing it or having awareness to it much earlier.
Yeah, there's so many different threads that I want to cover here. And I appreciate that example of someone with a fasting glucose of 102, because that was me when I was 35. I remember I got my fasting glucose back and I pinged my physician, primary care doctor, who was like, oh, you're fine. Stop drinking juice. And, again, I don't blame that guy, because I wasn't taught much in the way of nutrition when I went through my medical training. It's the sort of thing I had to teach myself. But this is something I love to do at parties. Remember, Casey, when we used to go to parties? So at parties, I like to ask people, hey, what's your fasting glucose? Do you know? And most people have no idea. Occasionally I'll have a taker who will look it up on their iPhone and get into their electronic health record portal, and they'll be like, oh, I was 103. That's pretty good, right? And I'm like, no. So I think we have to really change the way that we think about this type of testing. The other issue, of course, is that the standard is you get a fasting glucose, maybe a hemoglobin A1C once a year. So that is this tiniest little blip of time in terms of looking at what's going on with your metabolic health. You've got a needle in the vein for 30 seconds, maybe. You've got this 30-second snapshot of, what was going on with your sleep last night? What did you eat yesterday? How much exercise did you have? Did you exercise this morning before you gave a fasted sample? So it gives you that quick little snapshot. Whereas we now have the capacity and the power to get much more dense data. So that includes continuous glucose monitoring. It includes, you don't have to buy a CGM. You could actually get a little glucose meter and you could look at your fasting glucose over time. You could do N of 1 experiments. You could do postprandial glucose, 1 hour postprandial, as part of seeing what carbs you respond to and seeing what food is the best for you. So I think we need these much denser data sets, which is the kind of work that I do in my medical practice. And it's also what I do in a research setting. So the work that I'm doing right now is looking at the earliest biomarkers of that transition. If we put on our systems biology hats right now, if we have like a quick little nerd moment, there's this transition from health, which we're so lousy at defining in mainstream medicine. We define it as the absence of disease. It's like the circular argument that still centers us around disease. So with health, we want to really define that using the metrics that a patient values the most. And then we want to look at these transition states from health to pre-disease on to disease, and then ideally how to reverse the disease or reverse the pre-disease. So in this case, with metabolic health, we're looking at, in my research, the transition from health to pre-disease. We want to understand what are the drivers. So we know, for instance, that fasting glucose is a pretty late event in the spectrum of disease. We know that there are other biomarkers that are much more sensitive that start to change way before you see a change in fasting glucose or even postprandial glucose, such as adiponectin, such as CGM dynamics, such as fasting insulin and postprandial insulin. You sent me a paper recently from the Lancet where they were looking at civil servants in the United Kingdom, total of about 6,500 of them, published in the Lancet. What they did is they followed these folks prospectively over a pretty long period of time, many years, and they found that the people who made the transition to type 2 diabetes had changes in their insulin going back to 13 years before that. So this is flying below the radar of mainstream medicine. If we could get better at understanding some of those biomarker changes, it would allow us to intervene sooner when there's a much greater chance of reversal of getting people to go from that metabolically inflexible state back to a state of health where they're metabolically flexible. So there's a lot of different biomarkers that we're looking at. I'm up to more than 100 at this point. And so we're doing a systematic review and meta-analysis so that we can compare the time course, the time series of these biomarkers. I mentioned a few of them. There's a long list. There's fructosamine. There's ALT, one of the liver enzymes. We can look at
inflammatory markers
like high sensitivity C-reactive protein, the interleukins, other adipokines, leptin. We can also look at metabolomics, which is like this global interrogation of all those biochemical processes that can lead to metabolic inflexibility. We can look at proteomics, microRNA. So there's a long list of things that we are looking at. We're still in the early stages and, extracting data and understanding what the quality of evidence is for these different biomarkers, with the hope that we could come up with a picture that is a great improvement over using fasting glucose as a way of diagnosing prediabetes. Or, occasionally patients get a 2-hour oral glucose challenge tests, not many, but that can also be helpful in terms of diagnosis, or hemoglobin A1C. But what we know is that glucose doesn't change so much. When you look at the predictability of it, when you look 13 years later at insulin levels, that is much more predictive.
This is just, I mean, it is so groundbreaking what you're doing, because I think two big reasons, many reasons, but one is just because, like you said, the way we're looking at this glucose, people might think, oh, prediabetes or type 2 diabetes is a disorder of glucose being elevated, when in fact that is like such a downstream part of this mountain of other things that are happening physiologically in the body that ultimately result in that readout, essentially, and that end stage sort of dysfunction. And we're just missing right now that entire bottom of the iceberg, mountain, whatever you want to call it, of before we get to that readout. And so the way we've approached it diagnostically has, I think, created a misperception in our minds of the framework we have for what this actually is, when in fact it's a very complex disruption of many different pathways that can ultimately result in elevated glucose levels. And I'm curious, in the work in your research so far, do you have a sense that there are different kind of flavors of progression towards metabolic dysfunction, with sort of different sets of biomarkers that may be off and different physiology, or that there is sort of one core progression towards diabetes and ultimate sort of metabolic dysfunction?
Yeah, that's really one of the central research questions that we have, because we know if you look at type 2 diabetes that there are subphenotypes. So there's 3 subphenotypes that were published by Joel Dudley in an analysis that he did at Mount Sinai. I've heard some talks by Jessica Mega at Google, who's talked about 6 different subphenotypes for type 2 diabetes. So I know that there's at least that number of subphenotypes when it comes to prediabetes, and maybe even more. And the ones that I'm especially interested in is, how do we figure out those people who are most amenable to diet, lifestyle, nutritional redesign as a way of reversing their metabolic dysfunction? You said another thing that I think is really important, which is the complexity of this system. So, I wish it were a yes/no answer on metabolic flexibility. I wish it were a yes/no answer for whether you have prediabetes or not. Turns out it's much more of a spectrum. And as we understand some of these drivers and how the signaling pathways change, I think it's going to help us unravel some of that complexity so that we have more of an understanding about what we can do about it. And hopefully that'll help with the buy-in of our conventional medicine colleagues.
Absolutely. And one thing we haven't really touched too much on in this discussion of sort of the biomarkers associated with prediabetes is the genetic component. And I think that's one that's really interesting to people, because you hear a lot of people commenting on things like, oh, diabetes runs in my family. And the implication of that statement is that this is a genetic disease. There's a strong genetic component. There's an inevitability to it. And yet a lot of research suggests that well over 70% of cases of type 2 diabetes are probably preventable. And so there's this, and I would say, just thinking back on medical school, like I can't really remember a single genetic pathway I learned that was associated with diabetes. And of course, there are many. They could range from insulin receptor differences to pancreatic beta cell function or whatever. But I'm really, this to me seems like there's still a bit of mystery around how much of metabolic dysfunction is genetic. And if there is a large component to it that's genetic, are there lifestyle and environmental factors that could still move those pathways sort of in the right direction? So based on your research, what have you sort of been discerning around the genetics of metabolism, and what that means for the average person in both the way they frame just the concept of diabetes or metabolic dysfunction, and also what they can can do about it. And I know you also have work with, you've showed me reports from different genetic sequencing companies you've done. So maybe touching a little bit on the testing as well, if you would.
Of course. Yeah, it's a great question. If we look first at heritability, we know that with type 2 diabetes, it's somewhere around 20 to 70%. So you're right that heritability, I would say, the reason why the range is so wide is because there's so much complexity to this system. And what I understand from looking at the literature on the genomic pathways of glucose and insulin is that there's so many different genetic variations involved. There's literally hundreds of them. And then there's also gene-gene interactions that we need to pay attention to, transcription factors, and so forth. That being said, there's still, I think, a lot of value to understanding genetic risk, and then how do you adapt the environmental response to try to reduce the impact of that genetic risk. So this then gets us into epigenetics, which is yet another class of biomarkers that we're looking at, one of the buckets of biomarkers that we're looking at in our research. So when you look at genetics, a couple of things about that. The genetics of type 2 diabetes are more heritable than type 1. A lot of people don't realize that. If you look at twin studies, for instance, if you have identical twins and one of the twins develops type 2 diabetes, the risk is somewhere around 75% in the identical twin. And, if I could get my hands on that other twin, hopefully I would make that even lower. Totally hypothesizing there. But in terms of these genomic drivers, what I did was, as part of this pre-diabetes research, I wanted to look at genomics as one of the variables. And so I looked at some of the different scoring systems that are available for nutrigenomics. So really understanding how your genes are interacting with your food. And there's now a couple of scoring systems. There's one by Grimaldi from 2017. There's also one that was developed by a colleague and friend of mine, Yale Jaffe, who's a dietitian and also a genomicist, together with one of her colleagues, Annalise Smith. And I was showing you some of that information when we were having dinner together a few months ago. So one of the things that she came up with is a scoring system that then feeds into an algorithm to look at a set of 134 SNPs, many of which are involved in glucose and insulin. So I'm using that as part of my research. That's the particular scoring system that I'm using. And one of the things that I think is important, this is what I always start with when I talk to patients about genetics, is to start with some of the protective SNPs. So there's a few protective SNPs, such as FOXO3, CAT, UCP2, and then there's the whole list of risk SNPs. And this, I didn't do this original research, so I have to read some of this off, but these are pathways such as energy regulation and obesity, such as FTO and ADRB2. I happen to be homozygous for that one. That's the one that makes you have lifelong problems with your weight. That's me. SNPs that influence glucose and triglyceride clearance. That includes ApoA2, which, by the way, is a SNP involved in your response to the ketogenic diet. So important to know about. It relates to the risk of insulin resistance in response to saturated fat. So that's a good one to know about. There's a long list there, including CETP, which is involved in cholesterol. That's another SNP that's involved in keto response. There's the insulin resistance genes, including IRS1, PPARG, and DIO2, which is also involved in thyroid metabolism. There's liver gluconeogenesis, energy balance pathways, FOXO, transcription factors, vitamin D pathways, really important for glucose metabolism. And then there's the basic cellular pathways, of which I think of four main ones. That's part of this test called 3x4 genomics that I like to do on my patients and in my research. And that includes oxidative stress, inflammation, as you mentioned, detoxification, and methylation. So those are some of the cellular pathways that then map onto the insulin and glucose pathways.
Amazing. I think something you just mentioned there about the gene that's associated with, or the SNP, and for people who aren't familiar, what SNPs are, single nucleotide polymorphisms, essentially a single change base pair in the genetic code that can change the function of the ultimate protein that is expressed. And that there's literally a gene that has a SNP that changes the way you respond to saturated fat in terms of insulin sensitivity. I mean, if that's not sort of a window into why we need personalized diets and need to understand diets for our own body, like I don't know what it is, because someone who might really be struggling with a traditional ketogenic diet, very well could have something like this going on. And so I love that example. But I also was noticing when you were talking about that you're homozygous for a SNP that has to do with sort of lifelong weight storage. Obviously, you are super fit and, are not dealing with this issue now because of the way that you've chosen to live your life and the choices you've made. So I wonder if you could speak a little bit to that, of how having this information, which can seem really complex, can help kind of guide our decision-making towards maybe overcoming potential risk profile. And I guess what I'm kind of getting at is to also just sort of hear your thoughts on, for the average person out there who might be listening, is developing these diseases inevitable, based on family history or genetics, or is it something that we actually have a lot of sort of control over?
You have a lot of control. I think that's really the summary of the Human Genome Project. We were so excited for the Human Genome Project to get published. And in 2003, like, the party never really happened because we thought this would completely transform medical practice. And it turns out that, genes load the gun, but environment pulls the trigger. And so the idea here is that you have a lot more control and power than you might realize. And we're still in the early stages of understanding that control and power. So I mentioned my lifelong struggle with weight, the gene that is related to that. All of these genes, I think, sound like license plates. They're really hard to remember. But this one, if I go back and remember, ADRB2, yes, that's the one that I'm homozygous for. So what this gene does, this doesn't say to me, oh, Sarah, forget it, like buy some fat pants and just, hope for the best. Like, that's not my conclusion from being homozygous for this particular SNP. My conclusion is, okay, it's going to take me so much longer than someone else who doesn't have these SNPs. So instead of, dropping 20 pounds on keto over a short period of time, I'm going to drop a much more modest amount of weight. And so it gets me to the mindset of being very patient, thinking a lot about my future self, thinking about what I want for that woman. And it gets me into this place of lather, rinse, repeat. It's like washing your hair. I just have to be really super consistent about the food I put on my fork. I have to be super consistent about the exercise that I get. I have to structure my day around the exercise because I know if I wait until 5 p.m., it is not going to happen. So it's those sort of lifestyle changes that I think are part of the purview of all of us, regardless of your genetics, so that we can really architect the type of lifestyle that best supports you personally.
Oh, that is such an empowering message. I mean, and to know these things, to have the data. I mean, I think big picture, no matter whether you have your genetic SNPs in front of you or not, that message is incredibly valuable, that we have a lot of control. Our genes are not our destiny. And really it comes down to consistency. Like, that is the hard truth, hard pill to swallow, but it's kind of the reality with metabolic health. It's one of the reasons why early on in the company, we really worked on talking about the concept of metabolic fitness as opposed to metabolic health. Because when you think about lifting weights or building muscle, no one's ever going to think that if you just like lift weights once a month that you're going to be, ripped. You got to go in and do the work regularly. And it's the exact same thing with a lot of these dietary and lifestyle factors related to our health. So I love that message. So one other thing I wanted to dig into a little bit with your research was whether you've seen any studies within the abstracts that you've been reviewing that have to do with whether continuous glucose monitoring features, so the dynamics of the continuous glucose monitoring curve, relate to future prediabetes risk. There's lots of different metrics, like that we talk about, things like glycemic variability or area under the curve after a meal, things like that. But has anything consistent been emerging based on what you've been seeing in the research?
A lot of things are emerging, and I can't speak to the quality of evidence behind them, but I can just maybe highlight some of the things that I think are interesting. So from the work of Michael Snyder at Stanford, your alma mater, we know that getting this dense data really changes our ability to diagnose metabolic dysfunction. So as an example, hopefully I'm reporting this correctly, maybe we could link to this study as well. In his work on glucotypes, he did a small study, just 50 plus people. But what he found was that if you rely just on that snapshot of fasting glucose and A1C versus doing a continuous glucose monitor, you're going to pick up 15% more diabetics, about 15% more pre-diabetics, 2% more diabetics. So again, that's an argument in favor of the dense data versus the very quick snapshot. We're also seeing, and I think you emailed me about this, so maybe you could speak to this too, we can riff together. We're seeing that, one of the cutoffs with 2-hour glucose is 140. And I think that doesn't work, actually. I think we actually need a tighter cutoff. What I see with my patients, and this is echoed in the literature, is that a mean glucose less than 100 with a standard deviation somewhere around 15 is a sign of metabolic health. So there's some people who restrict their carbs too much or they don't eat enough food who could actually achieve that. And that's not necessarily healthy, but I think it gets us to at least a more complete picture when we look at mean glucose. Now, you sent me an analysis from one of these papers where you went a little bit further. I don't know if you recall that, where there was like a 30% decrease, even in folks who had a 10%, spent 10% more time, less than 100. Am I getting that right?
Yeah, this was a really interesting paper that I hadn't seen before that was called New Insights from Continuous Glucose Monitoring into the Route to Diabetes. And what they showed was that continuous glucose monitoring, so this dense data that you're talking about, allows for a better type 2 diabetes risk development categorization than fasting glucose and hemoglobin A1C. And what they showed, so that, so you've got these people, they've all got the CGMs on, they're looking at times in different ranges. And they found that the percent time under 100 milligrams per deciliter in a 24-hour period was predictive of future type 2 diabetes risk better than fasting glucose. So basically, if you can keep your glucose under 100 milligrams per deciliter, or it is naturally, staying there based on how you're living and eating and whatnot, that is predictive of doing better. And what they showed was an increase in 10% in the time under 100 milligrams per deciliter resulted in a 0.69 odds ratio of developing type 2 diabetes. So if you can just keep your glucose over a 24-hour period under 100 milligrams per deciliter, you're 7/10 the chance of future development of type 2 diabetes, which was absolutely mind-blowing to me. I mean, those are gigantic risk reduction numbers. And it's not as simple as, like, what I would never want someone to interpret this data as is being like, okay, cool, I'm going to just stop eating to keep my glucose under 100, or cool, I'm just going to drink canola oil for the next 6 weeks because it has no carbohydrates and it'll keep my glucose under 100. Like, this was not an interventional study. And so there's not a good sense of what the diets were. But one thing I can hypothesize is that, a lot of this is going to have to do with, nutrient quality. And if, keeping glucose under 100 through having the metabolic machinery in the body that is ultimately functioning properly, not just by hacking the system necessarily. So that's a big caveat, I think, to this, which the paper didn't really get into, but I think it's a really hopeful message of the fact that these dense data, continuous monitoring technologies could pick up a lot more in terms of early diagnosis, and also help us figure out how to optimize what we're shooting for to reduce our risk.
Yeah, beautifully summarized. Much more complete than my quick summary, but I think that 31% reduction is really substantial. And that's with the most basic of analytics. Just imagine how much more data we can get the deeper that we look at this picture. You also said something so important, and I think you alluded to this in another podcast that I was listening to, where you said, you know, you could drink vodka all day long and have like a nice flat line with, you know, keeping your glucose less than 100 and your standard deviation, you know, at like 1. And that's not health. That's not what we're looking for. So we have to look at this bigger picture. We have to look at the microbiome. We have to look at the role of infection. We have to look at these lifestyle factors like stress and sleep and diet and nutrition, even supplements. We have to look at this much bigger picture and not just pigeonhole it in a particular way. So I love how you bring that complexity, that nuance to the conversation.
Well, thank you. And I think your research is what, and the ultimate, what you're already sharing, you know, through your content and all, and then what these papers are going to show with the biomarker sort of multi-omic assessment is just the depth of this complexity, and that there is no single pathway that we can hack to, you know, make this all work. But it really is a holistic picture, which I think you've brought into world in such a beautiful way. And I think that brings me to my sort of last question, which does focus on sort of more of that holistic and maybe more mind-body aspect of metabolic health, which circles back to your comment about interoception, which I think is so important. And like you said, something that is sort of lost on us maybe in modern living because of how we're just always running, we're always stimulated. We live in a hyper palatable, hyper stimulating world. So the idea of just like really tapping in to what's going on under the hood inside the body, which is, we know, is powerful for health outcomes. People with better interoception actually do better health-wise. I think an example of this is that if you can sit and sort of hear and sense your heartbeat, people tend to have better cardiovascular outcomes and things. So even like sensing what's going on is good for us. But I'd love to hear your thoughts on how people can maybe take a step towards improving interoception in their own daily busy lives, and what that could potentially unlock for them in terms of tuning into their bodies, but also potentially having kind of better health outcomes over the long term. And maybe just some of the ways that you also like to tap in and like really and check in with your own body.
Well, you just modeled it actually, Casey. So you were talking about interoception and sensing heart rate. When I heard you say that, I noticed immediately my breath slow down. Couldn't quite feel my heartbeat, but I could sense into the area of my heart and where I would imagine that I would feel it, or maybe, you know, up into my carotids. And that's it. I mean, it's not some super complex exercise. It's a matter of understanding what's true for you. And in some ways, you know, getting back to outsourcing your power to your physician, I feel like we are all our best physician. Yes, you want to have a collaborative partner. Yes, you want to really understand risk benefits alternatives for some of the choices that you're making, the decision making that you make in healthcare. But no one is going to know you like you do. So in terms of what helps with interoception, I can tell you what works for me and speak from that experience. One of the things I try to do on Zoom, because it gives us such an opportunity to do it, is to do these kind of co-regulatory activities and to model it for other people, like extending my exhale, purposely slowing down my speech so that I'm speaking on the exhale. So that I find is very helpful. But I also, as I mentioned earlier, my interoception kind of broke. Like it just broke in my 20s. And that's why I love wearables. I love wearables because, you know, my aura tells me when I'm traveling too much. It tells me when I'm spending too much time. I've gone through like 1,200 citations for this systematic review and meta-analysis. Sometimes it's kind of late at night because I've got a research meeting the next day. And so it tells me when I've overshot. sometimes it's easier to start with the overshooting and to recognize the consequences of it and then pull back and practice something different next time. So I think that's maybe a good place to begin. Do you have a favorite place to begin with interoception?
I think I'm really with you on wearables. I think it can be confusing for some people to think like, why would I want to go outside of myself with technology to bring myself back in? But the way I see it is that it is an uphill battle to be in touch with our bodies in the world that we're living in right now and the demands that are on our attention and our time. And what I love about wearables, and I've got the Whoop on right now, I've got my continuous glucose monitor on. I've used several other devices this morning, Lumen, Biosense. So what they do for me is they help me cut through that noise and understand what's really going on inside. And then I can reflect on how that feels. So the connection between what the data is telling me and then being able to loop that in with how I feel, it becomes a touch point for me to focus on the subjective component of my body. So, okay. For instance, this morning after the fast, my ketones were higher, my glucose was lower. And so it gave me an opportunity to say, how do I feel right now? Really check in. I wrote it down. And I actually was feeling how you were describing with that sort of ketone mind high thing, feeling really sharp and clear, a little floaty. But that to me, the wearables become this centralizing force around diving into the subjective objective relationship. That's kind of the tech version of it. The simple version of it that I would say plays out even more in my daily life is really just my heartbeat and my breath, from sort of more meditation practice. I consider my breath my most powerful, tool of anything I have, right? I mean, maybe other than food, but when I breathe into my heart, feel my heartbeat for a few moments, and like you said, like on a Zoom, I'll often take a moment after I finish talking to do that and reset. And it is just, I crave it now. I crave the moment that I can do that. And so that's kind of what it looks like for me. To be honest, I don't have a regular meditation practice right now, which I wish I did, but the intermittent using cues, like I just got a bunch of words out and now I want to take I need to calm down a little bit. I need to slow down. Those little cues, I now really feel like I look forward to tapping into that. So that's kind of the way I do it. And I was really inspired by a recent post you did about your morning routine and how you really intentionally take the time to start the day with some of this meditative work to kind of get into that maybe interoception mindset early on. So if you would like to share anything about your morning routine, I'm sure people would love hearing about that.
Well, first I want to honor you because I love the description you gave of really tuning into how you feel, such as when you woke up today with ketones that were 2.0. What I think that reflects is neuroplasticity. It provides us with this moment of really kind of dwelling and taking in what's true for us and then reinforcing it with writing it down. So I really appreciate that. So my morning routine, I've had a morning routine for many, many years. It's, I think, the key to career longevity. It's the key to avoiding burnout, which, as you know, we have very high rates in healthcare. What I'm doing right now is I get up. I used to have, a cup of matcha, and then I discovered that I can't tolerate any caffeine right now. So I make electrolytes. So I either make it myself, like with lemon and salt, or I use something that's packaged, designed for metabolic flexibility. So I drink about 24 ounces of electrolytes. I'm on here's another big glass of it. And then I breathe. So I like to go outside. Blessed to live in the Bay Area where I can get some of that morning light. This is typically pretty early in the morning. I do potato breathing right now because it helps me a lot with efficiency. I have a voice disorder from public speaking for so many years and not breathing correctly. So Buteyko breathing is a form of breathing that's highly efficient and allows you to, it's designed for people with asthma. It also helps those of us with voice disorders. My voice therapist taught me it. So I do that for about 20 minutes. Sometimes I'll read something sacred because I think that's a beautiful way to start the day. And that can be anything. My current sacred text is Byron Katie. I just love Byron Katie and the work. And it's helping me with someone in my life who is triggering me like a teacher. When I can hold it that way as a teacher can be very helpful. So that's my morning routine. And then I hop on that Peloton, get my fasted workout in.
Power zones.
Power zone training.
You got me into power zones and I am so grateful. Oh my gosh, Matt Wilpers, love him. But that is beautiful. And I just want to thank you so much for sharing so much today. I'm so excited about what we got to cover, your amazing book, which is just such a gift. So all your books are gifts. Your books have completely changed my life. I know I've told you this many times, but I'll tell our audience, reading the Hormone Reset Diet and the Hormone Cure were the things that really got me kicked off on thinking about systems and network biology and a functional medicine approach to health, and therefore taking me down the best journey of my life. So I really credit it to you, and I'm so grateful that you were willing to share your wisdom today on the podcast and to collaborate with Levels on research and work that I really hope the end result is that it creates a different ecosystem around chronic disease that is much more empowering to people and helps them understand how much they can do to thrive, and that it's a lot of it is pretty simple principles. And so thank you for the work you do, and thank you for coming on today. How can people find you and follow you?
Well, first, thank you for your kind words. It's one of my love languages, words of affirmation. So I so appreciate it. And just love the person you are in the world, Casey. You're such a shining light. And I just love your social media. I love all the content you put in the world. Thank you for that. And your delicious questions. It was so fun to hang out with you today. So the way that people can learn more about me is to go to saragottfriedmd.com. That's kind of the mothership, the website where most of the action is happening. I spend a lot of time on Instagram. That's the social media platform where I consider it a lab, a clinical lab. So I'm constantly experimenting and testing things there, testing infographics and other ideas. And then if folks want to learn more about Thomas Jefferson University and the work in precision medicine, you can Google Marcus Institute of Integrative Health. Maybe we can link to it. That's another great resource.
Perfect. We will link to all of this. And thank you so much again, Sara, for being here.
Thanks, Casey. Okay, bye. Bye, everyone.